The universe just surprised us. Again. Astronomers have found a massive new planet right next door in the Alpha Centauri system. This isn't some distant, unreachable world. It's an Alpha Centauri, the star system we've dreamed of visiting for generations. Thanks to the James Webb Space Telescope, we now know there's a gas giant orbiting our nearest stellar neighbor. Imagine discovering a new continent just across the ocean. Except this one is only 4.37 light-years away. For years, Alpha Centauri has been the focus of our hopes and stories. Now, it's given us a real, tangible world to study. This planet, dubbed Alpha Centauri AB, is a colossal gas giant, far larger than anything in our inner solar system. Its discovery forces us to rethink what we know about our cosmic neighborhood. The search for life beyond Earth just got a lot more interesting, and a lot closer. The real excitement isn't just the planet itself, but where it is. So close, we could send probes there within a human lifetime. Alpha Centauri AB is now our top target for studying planetary formation, atmospheres, and maybe even the conditions for life. We're not just gazing at distant stars anymore. We're peering into our neighbor's yard and finding something extraordinary. This changes everything. Alpha Centauri is no longer just a dream, it's a destination. And while this gas giant may not be home to life, it could have moons. And those moons might be the real prize. Where there are giant planets, there are often moons. And those moons could be the key to finding life beyond Earth. So what makes Alpha Centauri so special? It's the closest star system to our Sun, a triple star system in fact. Two of its stars, Alpha Centauri A and B, are similar to our Sun, orbiting each other in a cosmic dance. Proxima Centauri, a faint red dwarf, is technically the closest star to us. For centuries, Alpha Centauri has been a tantalizing what if there were planets there? The gravitational chaos of three stars made many doubt planets could form, but this new discovery proves otherwise. Alpha Centauri A is a near twin of our Sun, and B is a bit smaller and cooler, making them prime candidates in the search for Earth-like worlds. A planet in the habitable zone here would be the holy grail of exoplanet research. That's why Alpha Centauri has inspired bold projects like Breakthrough Starshot, aiming to send probes to the system. Until now, finding planets here was nearly impossible. The star's brightness drowned out any faint planetary signals. It's like spotting a firefly next to a searchlight. But with new technology and persistence, we've finally pierced the glare and found something that will keep us searching for decades. Alpha Centauri isn't just close, it's a mirror for our own solar system, and now a new frontier. The discovery opens up a whole new realm of possibilities for our nearest stellar neighbor. How did we spot this hidden giant? Credit goes to the James Webb Space Telescope, or JWST. JWST is the most powerful space observatory ever built, designed to see the universe in infrared, the light of heat. Planets don't shine like stars, but they do glow in infrared, and JWST is sensitive enough to detect that faint warmth from light years away. The technique is called direct imaging, literally taking a picture of the planet. The challenge? The host star's glare is millions of times brighter than the planet. JWST uses a coronagraph, a tiny mask that blocks the star's light, revealing the faint glow of the planet. Even with this, it took hundreds of hours of observation and advanced algorithms to tease out the planet's signal. After months of work, a persistent dot of infrared light confirmed the presence of a massive world. This is a triumph of engineering and ingenuity, pushing the limits of what we can see. Direct imaging is the future. It lets us not only find planets, but study their atmospheres directly. Let's be clear, Alpha Centauri AB isn't a place for life as we know it. It's a gas giant, likely even larger than Jupiter, with no solid surface and crushing pressures. Descending into its atmosphere would mean facing extreme temperatures and violent storms and deadly radiation. Life needs stability, water, and a surface or ocean, none of which a gas giant offers. Its atmosphere is a chaotic, swirling mix, and the deeper you go, the stranger the physics become. The planet's magnetic field likely creates intense radiation belts, making the environment even more hostile. But that's not a disappointment. It's what makes this discovery so thrilling. In our own solar system, gas giants like Jupiter and Saturn are orbited by dozens of moons. Some of those moons are the most promising places to search for life. The real story isn't the giant planet. It's what might be circling it. The discovery of a gas giant in Alpha Centauri begs the question, does it have moons? If so, could one of them be our first real candidate for life beyond Earth? The search for habitable worlds just shifted from planets to their moons. Why are moons so exciting? Just look at our own solar system. Jupiter and Saturn are surrounded by moons that are anything but dead rocks. Europa, for example, hides a vast ocean beneath its icy shell, possibly more water than all of Earth's oceans combined. Tidal heating from Jupiter's gravity keeps Europa's ocean liquid, and hydrothermal vents could support life, just like on Earth. Saturn's Enceladus shoots plumes of water vapor and organic molecules into space, hinting at a subsurface ocean. These moons show us that you don't need to be a planet in the habitable zone to have the ingredients for life. Even Callisto and Titan offer intriguing environments, Titan with its methane lakes and thick atmosphere. The lesson? The most promising places for life might not be planets but icy moons orbiting giant worlds. Protected by their planet's magnetic field and warmed by internal heat, these moons could be cradles for life. Our search for life has expanded, from planets like Earth to the hidden oceans of distant moons. The discovery in Alpha Centauri means we might find similar worlds just next door. The real treasure could be orbiting a giant, not the giant itself. The discovery of habitable moons in our solar system has changed everything. Giant planets can act as life support systems for their moons, providing energy and protection. Tidal heating from a gas giant's gravity can keep a moon's ocean liquid for billions of years. No sunlight required. This means moons don't need to be in the traditional habitable zone. They just need the right orbit around a giant planet. The habitable zone expands from a narrow band to pockets around each gas giant. A system like Alpha Centauri could have multiple chances for life, all orbiting one planet. The gas giant's magnetic field can shield moons from harmful radiation, while its gravity sweeps away dangerous debris. These moons are often rich in water ice and organic compounds, the raw materials for life. Combine liquid water, organics, energy, and protection, and you have a recipe for life, maybe even more promising than early Earth. Finding a gas giant in Alpha Centauri isn't a dead end. It's a signpost pointing us to where life might be hiding. Finding this planet is just the beginning. To find and study moons around Alpha Centauri AB, we'll need even more powerful telescopes. The next generation of ground-based observatories, like the Extremely Large Telescope and Giant Magellan Telescope, will have mirrors over 30 meters wide. These giants, with advanced adaptive optics, will give us the sharpest views yet of Alpha Centauri. They'll work alongside future space telescopes like NASA's proposed Habitable Worlds Observatory, designed to directly image Earth-sized planets and moons. With advanced coronagraphs and starshades, we'll be able to block starlight and analyze the atmospheres of distant moons. By studying their light, we could search for biosignatures, gases like oxygen, methane, and water vapor. The discovery of Alpha Centauri AB gives us a specific nearby target to focus our efforts. The search for life just got a lot more real, and a lot more urgent. This discovery changes our strategy in the search for life. For decades, we've hunted for Earth 2.0 rocky planets in the habitable zone of sun-like stars. But the universe might be more creative than we imagined. Habitable worlds might not be planets at all, but moons. Gas giants, once seen as uninhabitable, could host families of habitable moons. There are far more gas giants than Earth-like planets in our galaxy. If even a fraction have icy moons with oceans, the number of potential abodes for life skyrockets. Finding exomoons is tough. They're small, faint, and their signals are mixed with their planets. But new techniques are emerging, and Alpha Centauri AB is the perfect test case. This is a lesson in cosmic humility. Life could arise in places we never expected. The search is no longer just for another Earth, it's for any world with that one magic ingredient, liquid water. We're on the edge of a new era of exploration. The discovery of a giant planet in Alpha Centauri is more than an astronomical curiosity. It's a call to adventure. This quest connects us to our ancestors who wondered about the stars, and now we have the tools to find answers. The pursuit drives innovation, inspiring new technology and a new generation of explorers. Finding life on a moon in Alpha Centauri would be the most transformative discovery in human history. It would reshape our science, philosophy, and sense of place in the universe. Even if we find nothing, the journey itself matters. It gives us perspective and unites us in a common purpose. The search for life is a testament to human curiosity and hope. In a universe of endless possibilities, This is a journey worth taking.